All right, hello, ladies and gentlemen. Welcome back. Glad you could make it. So we're going to continue with our work talking about the curbside logos. Now, something that I wanted to take a look at that we didn't get a chance to discuss. Let's look here at side length W and W plus 8. And then this one we talked about was W and W plus 13. So when we multiplied these out, we had W times W plus 8 as our area, and this one being W times W plus 13. Area equals, and then let's go and put area equals there. So what happens in each of these cases? We have two different graphs, two different equations that both equal a total of 48. They each equal a total of 48. So let's go. I'm going to go into the graphing calculator and let's clear this guy out. X times X plus 8. Oops. Back that up. X plus 8. All right. And do our next one at X times, and then this is going to be the quantity X plus 13. So we wanted that one a little bit longer on the side. Now, as you can see right here, we have zeros at two different places. Notice we're going through the origin, and this looks like -8 and -13. Now what happens when we set this expression equal to 48? We set this expression equal to 48, or the y2. Our other option says, let's back this up, let's say y equals 48. All right, so I'm going to come all the way up here at y equals 48, and now this is where we're seeing our zeros of the functions when they're equal to 48. And here we got one here. Okay. I want it 3 and -13, and 4, no, 3 and -16, and 4 and -12. All right. So we're able to graph these at the y equals 48 line to be able to see what the particular zeros are, where the graph equals 48. In the context of the work that we're doing, we are locked in to 48. That's the size of our figure. So area equals 48. But we have all kinds of different options that we could use that says that area equals 48, right? 48 equals length times width. 48 equals length times width. So we want to be able to write this as a standalone expression that we can change the numbers. So we had 48 equals W times, whoops, I wrote X, W plus 8. 48 equals W times W plus 13. Now, can we change this to make it so that we are able to put in any number? That'll work out, that'll multiply to give me 48. So 48 equals X times X plus some number. We know we want the length to be something a little bit longer than the width. So plus B. don't know what it is. So we can substitute in any number that we want. So we're going to write kind of a standalone expression as 48, our total area, equals x squared plus bx. Oh, that b term of standard form, that's going to change, and that changes based on how much larger we want the length to be than the width. And to find the solutions of this one, set the expression equal to 0, so 0 equals x squared plus bx minus 48. And so we have a standalone expression that we can substitute anything in we want.